Hey, how's it going, everybody? I just finished recording a video about my updated study update, however you want to run it. But basically what I wanted to cover real quick with you guys is, I know I shot a NAT video, and at the end of it I kind of got lost as to what commands I needed to throw in there. I'm going to put together a good NAT video probably tomorrow, and it's going to be specifically, how NAT actually works, and go from there. So what I wanted to do with the new CCNA being rolled out, I wanted to cover a couple of things that I've seen in the new exam topics, so you guys can see it and actually be like, oh, that's what they mean. So as you know, at the CCNA level, let me move that off the screen, they only focus on single area Ospf. Well, I don't know any company, and I've only worked for a couple of them, that run a single area of Ospf. What does that even mean? Well, in order to reduce network bandwidth and other things, a lot of administrators will run multiple areas of Ospf, because what it does is it allows you to let's see here, my headset was bugging me. It allows you to optimize your network. What do I mean by that? Well, what that basically means is, if you have a large network design, say 5,000-6,000 users, a couple hundred routes, it's going to be a big routing table. So it's advisable, and this could be spread among several branch offices. It is advisable to break up as many of those branch offices into single Ospf areas and have all areas leading back to area 0. And that's a good idea if you can do that. So what I've got set up for you is area 0 as the backbone, and then area 1 as a multi-area. And R1 is sitting here. And what I'm going to do is this. I'm going to show IP protocols, and as you can see, the only protocol running is Ospf. And what I've done is I'm running for the entire 172.20.0.0 network, and it's running only in this octet of Ospf. So what does that mean? Well, show IP interface brief. If the IP address is not configured for Ospf, what do I mean by that? If this IP address is different than the network that Ospf will advertise out, then you won't get an adjacency to form with the remote router, and it has to be on the same subnet. So right now R6 is on a different network than R1. So as you can see, it's not going to be the same. So I'm going to turn on this guy so you can see fast 0/1 and fast 0/0. What I'm going to do on this guy is I'm going to console into R6. Okay, got a console session set up there. I'm going to go side by side just so you can see how this works. Single area Ospf is pretty straightforward. Matter of fact, we're already running it. There's only one area. There we go. And as you can see, area 0. The reference bandwidth is 100 megabits per second, which, in this case, can anybody tell me how fast the cost is on 100 megabits per second? Nobody? Come on. Really? It's 19. Come on, you guys should know that. The reason they go, hey, I'm wrong. I was thinking spanning tree. Cost for spanning tree. It's 1. It is the speed divided by the bandwidth. So if your link bandwidth is 100 megabits, it's going to be a reference bandwidth of 1. That's going to be your cost to get from point A to point B. If it's 1.5 megabits per second, it's going to be a cost of, you got it, 64. Well, how did I come up with that? So we're going to go serial 0/.102. And as you can see, oh, I got to go 00. Right. Where's it hanging up? Right. No, that's not it. Oh, it doesn't want to show me now. Where did I see that? You know, what's this? Show IP OSPF interfaces. There we go. Where'd it go? I just saw it. 32. That's its cost. 32. Oh, that's because it's multi-link. That's why. That's why. I'm like, well, that's not right. 64. Serial 0/1 right here. It's a T1. Because it is. Where is it? I lost it. I'll find it. I'll find it. Where'd it go? Doesn't say it. I'm looking for the speed. You guys are probably yelling at me going, hey, it's right over there. Well, anyway, 64 because it's a T1 speed. So, the reason the multi-link was 32 is because it's two 64s, or it's bonded together, so it's actually 3.5, or it's actually 3 megabits per second instead of 1.5. So the slower you go, the higher this goes. Just remember that. So, anyway, but this is what I wanted to do. On R6, we're going to do show IP interface brief. And right now, nothing's configured. I just had some egg rolls. They're not sitting too well. So I'm going to throw a different IP address in here because I want it to be a different subnet. So I'm going to type in config t interface fast 0/0. Type in IP address is going to be, we're going to do 10.1.1.1 255.255.255.0. No shut. That's the address I'm going to work with on that guy. Now I'm going to go to global config on router 1 and type in IP address interface fast 0/1. IP address is 10.1.1.2 255.255.255.0. No shut. So that'll bring up the link. Now I will be able to ping across. Ping 10.1.1.1. At least I should be able to. There it goes. You can see it. Now, you're like, well, wait a minute. How does that work? It's not routing. You're right. It's not. But it's directly connected. Show IP route. It's directly connected. Okay? So technically, it doesn't need to worry about it. But what we're going to do is we're going to do this. Remember that OSPF area thing I showed you like a minute ago? Show IP protocols. And you see how OSPF 1, process ID is 1, and this is for area 0. Well, that's this 172 network. Config T router OSPF 1. Now, here's the thing. I'm going to type in IP network. Type in 10.1.1.0 0.0.0.255 area 1. Enter. Okay. Same thing over here. Exit. Router OSPF 1 network 10.1.1.0 0.0.0.255 area 1. Now, let's let it do its thing. That should converge pretty quick because it's over a fast Ethernet connection. And it's a broadcast domain. So, we're going to let it do its thing. I think I did no shut and everything. I got pinged, so I know it's going to work. This GNS3 can be kind of slow, so we're going to give it a minute. Wait for it to converge. And go da 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 da. Dun, 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 dun. How come it's not converging? I don't know. I would have thought by now it would have been. So, let's... Oh! I wasn't patient. So, there it goes. Alright. So, now it's converged. So, show IP route. But you're like, well, wait a minute, it's still connected. You're right, it is. Now let's go to R2 and see if I can see the 10.1 network in there. And I do, but I don't get it. Why does it have that IA? Simple. It's called an inter-area route. As long as you look right here, IA. It's an inter-area route. Well, I don't get it. What do you mean? Well, an inter-area route allows you to have more than one area configured in the same OSPF autonomous system. It doesn't necessarily have to be... Let's scoot this up here. Hopefully it doesn't blow up on me. And then R6 will go back there. Now, and show IP route. Now, hey, it's kind of funny how I see all that type of stuff. As long as you're running OSPF, okay, and I'm going to go to R1. I'm going to do show IP protocols. And you're like, well, I see area 1, I see area 0. And you're like, well, I don't get it. That's okay. Areas are a beautiful thing. Because now, this guy, if I decide to go from R6 and try to ping the 192 network, will it work? Yes, it will. Well, how's that? How does it work? I don't get it. Simple. Because this guy is getting routes from this guy, and notice how show IP interface brief. This guy right here is 10.1.1.1.2, 10.1.1.2. Oh, let's highlight it. 10.1.1.2, 10.1.1.2. This guy knows how to get to this guy because this guy knows how to get to this guy. That's how that does that. So areas, like I said, allow you to break up your broadcast domains. So you can have 100 different areas. As long as they connect back to area 0, you will never have a problem. Well, what if it doesn't connect, directly connect? Well, that's okay too. OSPF has this fancy thing called a virtual link. And a virtual link is a way for OSPF to make it look like you are directly connected even though you're not directly connected. You're saying, I don't get it. So, what this would do is, I'm going to minimize all this stuff real quick. Now, this is a true CCNP topic. This isn't something that was a CCNP topic and they're trying to bring into the CCNA. This is way beyond anything CCNA. But I wanted to go over it anyway. Let's say, for instance, there was another router here. Well, actually, let's do, over here. And let's say that this guy isn't a stub router, meaning it's got to route out to somewhere else. Let's say there's a BGP connection between these two. Okay, R7 was just appropriated by your company. Your company runs OSPF. Well, this company over here didn't need a routing protocol because it only had one router. Well, that's okay. You can do that. But by doing that, it only had a static route out, so anything that didn't match internally, it shot out to the internet. And that's typically what's going to happen. If you only have one router, one edge router, and it's doing all of your internal routing, then that's pretty much all you're going to need. You don't need to sit up there and set up a routing protocol. A simple static route is going to do it all for you. So, what you could do is with this R7 is you could go use a BGP connection, and you could very easily configure a router ID, and you're going to need a router ID because that's the best way to do it. and you could go into R6 and say, actually, let's pull up R6 real quick. R6. And we're going to go config T. We're going to type in router OSPF 1 and type in virtual link. Actually, area 0, area 1, actually, let's do this, area 1, and then see how it says virtual link right here? We're typing virtual link, question mark. What's the IP address of the associated with the virtual link neighbor? Well, right now we can't do it because of the fact that we're not connected to it. But let's say we were. Well, what I would type in is, let's say the router ID of this guy, or the IP address, was 192.168. 192.168.1.1. Question mark. Now, what do I want to do with that? Well, that's it. Because you don't want to do anything else with it. So, you would hit enter, and that's it. Now, nothing's going to happen because nothing's connected. Okay? But if there was something connected, what would end up happening is there would be a tunnel going across BGP to this guy, and it would make it look like it was part of Area 1. But in reality, it's not part of any area because it's not got a routing protocol. So what you would do is you would have to set the IP address up. Now, what I'm not 100% on is if it's actually got to have OSPF configured on it. I think it does, but what it does is it makes it look like it's part of Area 1, which is directly connected to Area 0, but it's not physically connected. So, like if you take over another company and you need to be able to configure, get OSPF route, get this company's routes, these users' routes out to your users' routes and stuff like that. If your routing tables need to look the same, is basically what I'm trying to say, then this is how you would do that with OSPF. EIGRP, you don't have to worry about that because it doesn't have to be directly connected. So you could be, thousands of miles apart. As long as you have a connection through the cloud to get there, you should be fine. Now, that's going without saying. If you have a frame relay connection, let's say this guy over here connected to it. If you had a frame circuit connected to it, or an MPLS circuit, and you wanted to route OSPF over that, you could do that as well. Now, that's actually what you would do. So on R1, I'm going to take that out of there. But that's the idea. You would type in Area 1 virtual link, and that would tunnel to this guy, and it make it look like it's directly connected, but it really wouldn't be. That's how you do that. Now, like I said, I still have and show IP route. I'm going to ping 172.20.0.138, and I can ping it. I can ping 139 as well. Okay, I can probably ping www.yahoo.com. Okay, that's because it's not turned on. But let's trace to 192.168.1.1. Well, it's going to hit 10.112, which is this IP address, and then it dies, which is weird. I don't know why it does that. But anyway, the point was that I can get to it, and it's got links to here because it's connected. It doesn't have to be connected. It could be part of another router, but as long as this, like this interface right here, a fast 0/0 could be part of Area 0. This guy could be part of Area 1. As long as they are directly connected, there's no problem. That is my main point. So, for those of you guys that want to be advanced users, that's an advanced topic. So, at least to me anyway. So, that's pretty much it. That's multi-area OSPF. Not complicated. Really, really simple. So, again, I will do a show IP route. Anything directly connected will be C, obviously, because it's connected to it. These are inter-area routes, because it's going from one area to another. If it was intra-area, do I see? This would be like if you had what's the best way to put it? Well, in this case right here, you see an external route, E2 route. It means it's external, type 2. That basically just means it doesn't increment this guy right here. The cost doesn't get incremented. That's how much it costs, or that's the administrative distance, I'm sorry. That administrative distance doesn't go up with the advertised distance of the routing protocol it's going to use. You could set it up as an E1 route, but it's by default it goes E2, which doesn't increment. So these are all things that you need to keep in mind as the engineer. So that is actually kind of why I kind of push being well-rounded into your studies, because realistically, if you're not well-rounded, you're going to struggle, and nobody wants to struggle. So take your time as you're going through this stuff and make sure you understand it. Don't sit there and try to just run through it, get it done, and be like, well, that was cool. You need to actually get to know it. Like I said, I said in my study update that as I get through the CCNP switch and I get closer to taking my exam, I'll do a CCNP switch series where I'll walk you through how to do different things. It's my opinion, and actually a lot of engineers that I've talked with in the CCIE forums and on Cisco's website and their study groups, if you can't explain it to somebody in simple terms, even complicated scenarios and technologies, you're not ready for the exam, because they're going to test you at that level. They're going to say, okay, can you explain inter-area routes? Can you explain what a virtual link is? Do you know what it does? Do you know why they use it? Well, yeah. Well, can I troubleshoot it right now? No, I can't right now, because the fact that all I know how to do is basic implementation of it. Does it go beyond that? Yeah, it does. And you saw there's about 8 different options that were available with the virtual link. Now the idea is to go through there and actually poke around, figure out what happens. The CCIE training that's out there covers 95% of what's on the blueprint. It's your job to make sure that no matter what comes up in the technology, you should be able to have at least a basic understanding of everything that's there. Basic understanding. There shouldn't be a topic that they throw at you that you shouldn't be able to go, okay, well, it may take you a second or two to think about it, but at the very least you should be able to figure out how to do it. So, advanced topics, not necessarily, but core topics, core technologies. You should be able to get OSPF up and running, EIGRP, BGP, and that's actually going to be one of my next things is when I get done with this, is get EIGRP. I'll flip that over, and everything in here will be EIGRP. EIGRP plays a little bit nicer with frame relay. You don't have to be so stickler about it when it comes to getting it situated with the neighbor commands like you do in OSPF. But Rebecca wanted OSPF as a routing protocol. I made it happen. So what I'm going to end up doing is, and I wanted to show you this stuff so you could actually see how it works. It's not hard to do, because a lot of people freak out and they go, well, what's an inter-area route? What's multi-area OSPF? And they're freaking out because they don't know. So this is how you configure it. It's not hard. It's pretty straightforward. So, like I said, as long as you go through and you can understand the concepts and you can configure and implement it, break it. Do something wrong. Do it intentionally and then try to figure out why it did what it did. You know, no one's going to fault you for trying to do better. You know, and if you do better, that makes you that much better. You know, if you break something, that makes you that much stronger the next time it happens. And you're like, oh, well, I did this and this is the result. So, because like I said, you never know what, I mean, you can be fairly certain at the like the NP and the IE level that they're going to test you on a large section of that particular area. What I mean by that is like CCNP route. If you're going to deal with route and it's OSPF, you're pretty much going to know everything that they can throw at you at the CCNP route level. At the IE, game on. It's whatever they can throw at you. You know, they may, you know, half of your points might be in OSPF. OSPF is the most popular routing protocol in the world. So that being said, you better know it and know it well. And if you don't know it, well, you're going to struggle. So that's why it's one of these things where I'm going to put together a topology when I go through my CCNP route to where, and actually what I should do is I'll pull up my video series here, my video player, and I'll scroll to where I find my CCNP route. Where is it at? I do have a lot of series here on my computer, and I do have an IPv6 series as well. Let's see here, CCNA Labs, CCNA, and here we go. CCNP route. You have all of these. There's 28 videos. It sounds like a lot, but it really isn't. But actually, let me see if I can. It's cooking with fire. So what we're going to do is, as you can see, it starts at the top and talks about the certification and getting the most from the series. Yeah, that's all good stuff. That's actually, this is the guy that turned me on to GNS3 because I really didn't know how to use it, and then he walks you through a couple of different options for GNS3 and how to really get it to pop. And network design and documentation, comm system planning. These are all things you will need to know because they will test you on this stuff in the CCNP route in the exam. So, like concepts and planning, and then basic EIGRP, advanced EIGRP, best practices and design options, and then you'll see, let's see here, this I believe is frame relay over MBMA. It's really simple to implement. It's not hard at all to get it running. And then you get an OSPF. OSPF, it's more complicated. In OSPF, there's, let's see here, there are 1, 2, 3, 4, 5, 6, 7 videos. EIGRP is 1, 2, 3, 4, 5. Not as much to worry about with EIGRP as there is with OSPF. Then there's route redistribution, and he'll get into route maps and stuff like that, and complicated stuff, and path select, or how to get the right path and redistribute it the correct way. And there's BGP. BGP is it's not complicated, but it's one of those things where if you don't understand it, it's going to bite you. So a lot of the stuff I've actually been through all of these videos already, so I'm already familiar with it. So I'm going to go back through and watch these videos when I get to the CCNP route section. And then they have this thing called policy routing, and policy routing allows you to choose, using a route map, setting up access lists, and say, okay, well, if you want traffic to go, let's say for instance, this is an ISP and this is an ISP. If you want traffic to come in this direction, and if it's internet traffic, it's going to go out the faster link. But if it's database traffic, it's going to go to the left. Okay, and then over to a database server. But if it comes from a specific subnet of, say, the bosses, you want them to go out the faster route. Where if it's people that all they do all day long is just read, they do research, and they need to put documents together, and they need access to the internet, but they also need database, you're going to want them to prefer to go this way. And maybe this is an ISP and it goes out, then you have like Google Docs or something like that. You're going to have them route this way. So depending on what the situation is and whatever parameters you put to that will determine it. And then as you can see at the bottom, there's IPv6 routing. IPv6 routing is really not that complicated. It's fairly straightforward. It does take a little getting used to with the addressing, but if you take your time and you really learn it, you should be fine. And like I said, I do have a IPv6 series here that I downloaded from a friend of mine. Right here. Goes through everything you need to worry about with OSPF and EIGRP and BGP and all the things you need to worry about. Well, anything with IPv6 really. The nice thing about it is it covers our multicast. I'm going to go through all of these things because of the fact that it'll apply to the CCIE. So as long as you can do all of these, you'll be good. You'll be really good. And actually, what's funny is I went through IPv6 today at work, and it's kind of funny. The only thing that they didn't cover, they covered this first half with stateless auto addressing. That's basically DHCP. And then none of this stuff got covered. Let's see here. They did talk about RAs with route advertisements, or router advertisements. They didn't talk about firewalls or ASAs or security of it. They did talk about tunneling. Let's see here. There was nothing on MPLS in there, but it does support it because obviously MPLS is a service provider thing. But like I said, that's the stuff that you'll run into. But that's stuff that you'll get to see. It'll be something you guys can play with. But like I said, multi-area OSPF, pretty straightforward. Just it's putting it in a different area, and the routes look different. So actually, let me do show IP OSPF database. And you're like, whoa, wait a minute, what's this? Well, these are your link state advertisements and the router IDs. This will be the link ID, the advertising router, and the age, and all the stuff like that. Then the area that it belongs to, and summary routes, and these are your LSA type 1s, LSA type 2s, 3s, external routes, type 5 LSAs, way beyond anything at the CCNA level. I'm familiar with it, that's why I know what it is. So, that's it. I didn't want to freak anybody out or confuse anybody. So if you have any questions, shoot me an email. It's on YouTube. Give me a shout. I'll be happy to talk with you, give you some pointers. If you want to set up a Google Plus Hangout to where I can have GNS3 running, and you guys can ask me questions on different things, and I can explain it to my best of my abilities, and if I have to reference something, I can show you where I'm going. The nice thing about Google Plus is you can screen share, so I can choose what screen I want you to see, and I can pull up this, and as I'm going through it, you guys can actually watch it live, and it'll be full screen on your monitor, so you'll actually be able to watch me do it, and you can ask me a question, and I can talk to you via Google Plus. So you wouldn't be able to see me, but you'll be able to see my screen, and it'll be like me, but live. It'll be like this, but live. So it's cool stuff. So let me know. I'm always open for if somebody has a question or you think of a different way I should present the material. It's fine with me. One other thing I'm going to add in here is IPv6. So I will set up like IPv6 and I'll show you what dual stacking looks like. So, but that's another video down the road. So I hope this has been informative for you, and I'd like to thank you for viewing.